Hey guys, Ms. Gosling here. In this video, you're going to learn about circuit diagrams. By the end of the video, you'll be able to use circuit diagrams to represent actual circuits. So let's go ahead and get started. And we're going to start by actually talking about some of the common parts of a circuit. So depicted here is a really basic circuit with only a few simple elements that you guys are going to use a lot. So this is the exact kind of circuit you guys should expect to see very, very frequently in our class. So a couple of the elements in the circuit are ones that we're going to use very regularly. And the first one is something you are very familiar with, and that is the battery. Instead of a battery, we also might use a cell or a variable voltage source, which looks like a giant box with a dial that you can use to change the voltage in your circuit. And what that battery is doing is it is creating a potential difference. So what it does is it has a bunch of electrons gathered on one end and no electrons on the other. And those electrons that are all crowded together on one end are going to want to travel through my circuit to get away from each other and to spread out. And so our battery is what causes our circuit to go. Now, just so y'all are aware, our electrons are going to go around the circuit from the negative terminal of our battery to the positive. So again, they're going to go from the negative terminal of our battery to the positive. Because electrons are negatively charged, they want to go to the less negative part of the circuit. However, we've actually figured out that electrons were the charge carriers in our circuits after we learned that circuits existed and worked and could generate currents. And so when we defined the current, we actually defined our current, which we use the letter I to represent. We actually determined that our current would go from the positive terminal to the negative. So again, although the electrons are the thing actually moving, the direction of our electron flow is going to be opposite the direction of what we call our conventional current. And this is just one of those little weird quirks of physics that occurs when you invent electricity before you actually understand the electron. So with that brings us to the next circuit element, which is the wire. And wires are long pieces of metal that have very low resistance and are therefore very good at conducting electrons. So they're highly conductive materials. Next, we have our switch. And a switch is often a safety element of a circuit because what it can do is it can either close the circuit, allowing electrons to flow from the negative terminal to the positive terminal, or as you can see in the picture, in this diagram, it can also be opened, which prevents our electrons from flowing because they have no way to cross this gap here. So our switch is how we turn our circuit off and on. The next element of a circuit is something called a resistor. And a resistor has a constant resistance, and what it does is our resistor does is it requires our electrons to use some energy to cross our resistor. So in crossing the resistor, electrons are turning electrical energy, we're turning electrical energy into some heat energy, and as a result, we're going to have a voltage drop across the circuit. So there's going to be a little bit less energy after our resistor than there was before. Next, we have our bulb. And in our light bulb, our electrons are being used. Again, they're doing work. And in this case, what they are doing is they are lighting up our light bulb. So we're turning electrical energy into light and heat. So these are our key circuit elements: our switch, our voltage source, so a battery, cell, or variable voltage source, our wire, our resistor, and our bulb. Now, the thing is that drawing that circuit is really not that easy. Thinking about if I was going to try to draw my battery and then add in a switch of some kind, and then maybe I want to draw this resistor with its stripes, and then, oh my god, a light bulb. I can't draw light bulbs. That's so hard, right? So drawing our circuits, we want to make sure that it's clear what every element of the circuit is, regardless of the artistic ability of the person drawing that circuit. And so that brings us to circuit diagrams. So first of all, we have our wires, and wires are easy. We represent them with a straight line. Now, say that we have a place where we have two wires coming together. To represent that, we're going to use a dot where the two wires connect. If instead we have a circuit where we have one wire going from left to right and another going up and down, but they don't touch, so they aren't connected, you'll see we do not have a dot here, and that's representing the fact that our wires are crossing over each other but are not joined. So we don't have current traveling from our horizontal wire to our vertical wire. Next, we have the cell, and your basic cell is represented like so, with one long line and one short line parallel to one another. The long line is going to represent our positive terminal, and the short line is going to represent our negative terminal. We do not need to add in the positive and the negative sign because that is understood in the design of the symbol. Now, if we want to specify that we're using a battery rather than just a generic cell, what we're going to do is we're going to take two of our little cell symbols and connect them together like so with a dotted line. And again, we have the positive terminal and the negative terminal of our battery. Finally, we can have a variable power supply. And again, those are generally a big box with a dial that you can use to change the voltage of your source. And to represent our variable voltage supply, we're going to take the battery symbol and draw an arrow over it to represent the fact that we are varying our voltage. So that arrow in general represents a variability of some kind. So next you have our bulb, and there are a few different symbols for a bulb or a lamp. But in IB physics, we're going to use this symbol to represent our lamp. So that is a circle with an X in the middle. Another common symbol for a bulb, just so you guys are aware, looks like that. But we're not going to use that in this class, so you don't need to worry too much about it. So next we have our resistor. And we have our very basic resistor, which is going to just be represented by a rectangle. If we want to represent a variable resistor, we're just going to draw an arrow pointing diagonally up and to the right over our resistor, over our rectangle. Now, just so you all are aware, again, the IB symbol is a little different from your typical American symbol. So if y'all are going off to college and studying electronics, or if you're taking the ASVAB test or something along those lines, you should expect to see this symbol instead. And again, that's just a difference between the British and American systems. So next we have our switch, and switches are easy. They are just going to look like this. They look exactly like how you would draw a switch if you were just going to draw it on your own. So these are our key circuit symbols for our basic circuit element. So now let's take our original circuit and draw it using our circuit diagram symbols. So let's start with our battery. We're going to represent that using our battery symbol, like so. And following the direction of current flow, that's going to bring us to our light bulb. And you'll notice I don't worry about the shape of my wires in my circuit. Generally, we like our circuit diagrams to be nice and rectangular because that makes them easier to read. So anyhow, I'm not going to worry about these diagonal lines like this. So we have our lamp, and then after that, we have our resistor. So I'm going to represent that with a box. Next, we have our switch. And then finally, our wire reconnects back to the negative terminal of the battery. And you can see I've actually drawn this backwards because our positive battery terminal is here. So really, what I should draw is a circuit that looks like this. My current is going to flow from the positive terminal of the battery to the negative terminal of the battery. And my electrons are going to be which are the actual thing moving in my circuit, are going to flow from the negative terminal to the positive. And this is a circuit diagram for the circuit that we looked at in our first slide. Now, the other thing I'd like to discuss is how we can actually measure the current and the voltage in the circuit. So current is going to be our flow of charge. So that's going to be our change in charge, which we're going to use the letter Q to represent. over time. And we're going to use the letter I to represent current. We're going to measure our current in amps, which we use the capital letter A to represent. Now, we use a tool called an ammeter, which is what this guy here is, to represent or to measure our current. And we always want our ammeter to be connected in our circuit. So we want it to be connected in a line with our bulb and our resistor. And the way that we talk about this is we say that it is connected in a series with our circuit elements. So our current has to go through our ammeter before it can go through our bulb and our resistor. And it's very important that we put our current in the circuit itself. Otherwise, our current has a really low resistance. And so, our ammeter has a really low resistance. So our electrons are going to try to travel through the ammeter instead of traveling through our bulb and our resistor if we put it in our circuit the way we have our voltmeter here. And that brings us actually to our voltmeter. So our voltmeter measures the voltage in the circuit, which you can see here. Voltage is the electric potential of our circuit, so the ability of our battery to do work. We are going to measure our voltage in volts, and both voltage and volts are represented using the letter capital V. So we would say that our voltage, for example, is 0 volts in our circuit, which I know looks a little weird, but I'm sure y'all will get used to it. Now, when we connect our voltmeter to our circuit, we want to connect our voltmeter across a circuit element. So instead of having it in line with our circuits, instead of having it in a series, we want it to be what we call parallel to circuit elements. And that is so that it's measuring the voltage drop across that element, because there's not really much voltage drop going on across any of our wires. So to represent our voltmeter and our ammeter, we also have additional circuit symbols, but they're very similar. So an ammeter is a circle with an A in it to represent ammeter, and our voltmeter is represented with a circle with the letter V, which stands for voltmeter. Now, drawing our circuit diagram, we have our cell again, and then connected to that we have a lamp, and we had our resistor, and we had our switch. And when I created my circuit, I put my ammeter in a series with my circuit. And I could take this ammeter if I wanted to, and I could move it. I could put an ammeter here if I wanted to instead. I could put it here. It doesn't really matter where it is, but it does need to be in that series, in that line of that loop of my circuit. And then I took my voltmeter, and I had it connected across my resistor. So whenever you're putting ammeters and voltmeters into your circuit diagrams, I'm going to look, is your ammeter in a series with your circuit, and is your voltmeter in parallel? So with that brings us to our takeaways. First of all, circuit diagrams make it easier for us to accurately represent circuits. Second, ammeters need to be placed within a circuit, so in series with circuit elements, and voltmeters need to be placed across a circuit element, so parallel to that circuit element. And with that, you have learned about how to create circuit diagrams, and you have learned about some of the key components in our circuits. So with that, it is time for you to learn a little more about the relationship between voltage, current, and resistance in our video on Ohm's Law. Best of luck, and happy solving.